Solve the given system of equations using substitution. Here, we want to solve this system of equations. We've been given two equations, each with two unknown variables. Now, our job is to find any ordered pair that satisfies this system. Any ordered pair that, when we plug it in, will create a true statement for both of these equations. So let's take a closer look at these equations. We have y minus x equals -3 and x squared plus y squared equals 17. Notice, this second equation involves an x squared term. So it's possible that this system could have more than one ordered pair that's a solution. But there's only one way to find out, to solve this system. And we need to solve this system using the substitution method. That means we want to take one of these equations, solve it for one of the variables, and then plug that into the other equation and solve. So let's go ahead and do that. And to help us keep track of these equations, let's go ahead and label them. Let's take this first equation and label it equation A. And we'll take the second equation and we'll label it equation B. Now we need to choose one of these equations to solve for a variable. And it doesn't matter which one we pick. Well, equation A looks like it may be easier to solve for than equation B. So let's go ahead and focus on solving using equation A. Now we need to pick which variable we want to solve for. And again, it doesn't really matter. So let's go ahead and take equation A and solve it for the variable y. So equation A is y minus x equals -3. Again, we're just choosing one of the two equations and solving for one of the variables. And we chose to solve for y. So we want to get y completely by itself. That means we need to add x to both sides. And we get y equals x minus 3. So we now have equation A solved for y. Y is equal to x minus 3. Perfect. Now, following the substitution method, we need to take our other equation, equation B. And we need to write equation B, but we need to plug in what we just found for y using equation A. So let's go ahead and write down equation B. We have x squared plus y squared equals 17. Now we need to write this, but anytime we see a y, instead of writing y, we write what we found y to be equal to, x minus 3. So let's see, we have x squared plus y squared. Well, we solved the first equation and found y to be equal to x minus 3. So instead of y squared, we write x minus 3 squared. And that's equal to 17. Now look at what we have. We have one equation with just the variable x. We want to take this equation and solve it for x. But to help us do that, let's go ahead and simplify things a bit first. So we can bring down this x squared. And if we look here, we have x minus 3 squared. Well, there we can use the square of a difference formula to simplify. X is our first term and 3 is our second term. With the square of a difference formula, we take our first term and we square it. Then we subtract 2 times the first term x times the second term 3. Then we add our second term squared. So 3 squared. And that's still equal to 17. Now let's simplify. X squared and x squared are like terms. So adding those together, we get 2x squared. Here, taking -2 times x times 3, we get -6x. And 3 squared is 9. Perfect. Now take a look at this equation. Here we can see we're dealing with a quadratic. So let's go ahead and focus on solving this quadratic for x. That will give us our value, or multiple values for x that work with this system of equations. Now, to help us solve a quadratic equation, it can be helpful to take everything and move it to one side. So let's subtract 17 from both sides so that all the terms are on one side. When we do, we have 2x squared minus 6x, and then 9 minus 17 gives us a -8. Now, take a look at these terms on the left. We have 2x squared, -6x, and -8. Each of those can have a 2 factored out. So, if we divide both sides by 2, that will factor out that 2. 2x squared divided by 2 just gives us x squared. -6x divided by 2 gives us -3x. And -8 divided by 2 gives us -4. Over on the right, 0 divided by 2 is just 0. So we get this slightly simpler equation. x squared minus 3x minus 4 equals 0. To help us solve this equation, let's go ahead and see if we can factor it into the product of two binomials. Well, let's see. X squared is our first term. So, in each binomial, the first term will be an x. If we take a look at the sign in front of our third term, we have a negative sign. That means that we will have opposite signs. One binomial will be subtraction and one will be addition. Now, to figure out these last terms in each binomial, we need to find two numbers that when we multiply them together gives us negative 4, this last term, but when we add them gives us negative 3. Well, if we put a 4 here and a 1 here, that would work. X minus 4 times x plus 1 would end up giving us this original polynomial back. So now we have factored the polynomial on the left into the product of two binomials. And now we can solve this using the zero product property. We can split this up into two equations. We can have x minus 4 equals 0 or x plus 1 equals 0. So let's solve each of these for x. To solve this equation for x, we add 4 to both sides, and we get that x is equal to 4. Over here, we subtract 1 from each side to solve, and we get that x is equal to negative 1. And look, we actually found two values for x. That means that we will have more than one solution to this system of equations. But in order to find the rest of the ordered pair, we still need to find the corresponding y value for each of these x values. So that means we have another step. We need to find those corresponding y values. To help us do that, let's just take a look at one of the x values that we found. X equals 4. Now, we want to take this x value and find its corresponding y value. And to do that, we can take this x value and plug it into either of these equations in our system. It doesn't matter which one. Remember, we're searching for an ordered pair that when we plug it in will satisfy both of these equations. So plugging in x equals 4 into either of these equations will give us the same y value. Let's go ahead and pick equation A, since it looks like the easier of the two to work with. So we have y minus x equals negative 3. We found x to be equal to 4, so we plug that in. And we solve for y. So we add 4 to both sides, and we get that y is equal to 1. So when x is equal to 4, y is equal to 1. This is one of the solutions to our system. Great. Now we just need to repeat that process with our other x value. X equals negative 1. So again, we take this x value and we plug it into either of these equations in our system. Let's go ahead and pick our first equation again. It doesn't matter which one we pick, but this one looks like the easier of the two to work with. So we plug in our value for x. X is negative 1 in this case. So here we're subtracting a negative. Well, that's the same thing as adding a positive. So we end up with y plus 1 equals negative 3. Solving for y, we need to subtract 1 from both sides, and we get that y is equal to negative 4. So here, when x is negative 1, y is negative 4. And we have another solution to our system of equations. So here, we found two solutions to our system. Both of these ordered pairs satisfy these equations. And we could check that by graphing each one of these equations and seeing where they intersect. If we did that, we would find that they intersect at 4, 1 and negative 1, negative 4, our two solutions to this system of equations.